Hello, what's up, guys? Welcome back to ReddyControls. Most people think T off timers are just for keeping fans running after motor shuts off. But in real automation environments, T off timers can do so much more. In this video, I'm going to show you 5 unexpected ways you could use the time off delay timers to make your logic smarter, safer, and more reliable, all backed up by real PLC code examples. Let's get into quick recap. A T off or a off delay timer turns on instantly when the input is true, but once the input goes into false, the output stays on for a preset time, say 5 or 10 seconds before it shuts off. That's what makes T off timers perfect for cases where you want to run something to linger after a condition ends. In this video, we're going to talk about 5 use cases for off delay timers. The first use case is post-cycle cooldown, where after a heater finishes its job, the fan should run for additional 10 seconds to cool the material and prevent sealing issues. This is used in packaging and food industries. And the next example we're going to cover is a delayed alarm silence, in which alarm sound is silenced immediately, but the visual strobe light remains on for 10 seconds to log the event visibly. Next use case is a retract cylinder delay. This is useful when a sensor detects a part in position, but when the part leaves, the cylinder should wait at least 3 seconds before retracting. This prevents jam ups or causing a damage to the part. The next use case is about a safety buzzer hang time. When a e-stop is cleared or resetted, operation should be alerted that the system is. And the final one is about smart energy savings, where a motion sensor can be used to turn on the lights off, to auto turn the lights off after a few minutes of inactivity. Go into the video. First up, post-cycle cooldown. Imagine you're running a heat sealing operation. After the heater shuts off, you want a fan to keep running for 10 seconds to cool down the material and prevent sticking. Here, if you look at the logic here, I'm just using a start and a stop circuit, which will turn on the heater. And once the heater is turned off, the off delay timer is going to start timing. And after 10 seconds, the timer is timing. We use that time off, T off delay dot timer timing bit to turn the cooling fan on. And once the cooling fan is on for 10 seconds, we'll call a cycle complete bit. So we'll go ahead and reset the cycle complete. Cycle is complete. So we'll go ahead and start the cycle now. We'll do that by hitting the start push button, and the heater is on. After some time, we do a stop push button, which turns the heater off, and you could see the cooling timer, the T off cooling time off delay is on, and the fan is on during that time. So we'll repeat the cycle again. I'll zoom out a little bit. You can see the whole cycle. So we do start the operation. This gives you automatic cooling without any extra logic or manual reset. I'm using the timer timing bit to energize the fan while the timer counts down. So I'm hitting the stop push button. You could see the cooling fan came on, and once the 10 seconds is done, the cycle is complete and the fan turns off. Now we go into the next example, where we're talking about a delayed alarm silence. Say an operator presses a silence button to mute an alarm. You want the buzzer to stop immediately, but the strobe light needs to remain on for 10 more seconds, so the supervisor still knows there is a recent issue. Here is how we are doing it. We use a right now I'm using let's, instead of a start button, let's use a reset button. Using the reset button as a silence for now. So once the reset button is pressed, we make a tag called silenced PB, and once that PB is on, we use alarm silence, and we use alarm silence bit to turn on. Silence bit being low will turn on the timer off, and while the timer is timing, we turn the strobe light on. It's a lot of redundancy here, but it could be simplified. I could just use the reset push button directly to click here in this one. But for now, we'll go ahead and reset. Alarm is silenced, and once I let go of the reset push button, the timer starts timing, and we use the off delay timer timing bit to turn a strobe light, and the strobe light goes off. So this is extremely useful if you want the visual indicator on, but don't want to annoy everybody with a buzzer. Okay. The next case is pneumatic cylinder retract delay. In this one, say we have a sensor which picks up a part, and the part is present, and part is detected to be in front of the retract cylinder. But what we want to do is we want to retract the cylinder back only after 3 seconds. After the part leaves, we wait for 3 seconds before retracting the cylinder. This helps in not causing any jam-ups or prevent any jam-ups. So what we're going to do is we'll say part is present in front of, we'll just toggle this bit saying like there is a part present in front of it. The cylinder extended it and it pushed the box, but we want to wait 3 seconds for the cylinder to retract before it could retract, that to avoid potential jam-ups. And all we do is we toggle the part present bit low, that turns the timer on and the cylinder retracts. Simple application there. And the other example we're going to talk about is a safety buzz hang time. Say when someone, this application is about safety. So when someone clears the e-stop, I want a buzzer to sound for 3 seconds to alert the team that the system is restarting, even though it's technically safe. This is where the T off shines. When the e-stop input falls, the timer starts. While it's timing using the timer timing bit, the buzzer stays on. After that, the buzzer stops and the operator knows it's safe to proceed. It's an elegant way to add soft safe clear without extra hardware. Say we have e-stop not okay, the machine stopped, and we'll hit the, so we go ahead and push the reset push button. We clear the e-stop, so we go ahead and toggle saying like e-stop is okay now. And now when they reset the machine, you have a buzzer beeping for 3 seconds to alert that the machine is about to start. I'll run it again. E-stop is not okay. Machine stops. We reset the e-stop and we hit the reset button. When we hit the reset button, the buzzer comes on saying like the machine is about to start. Moving into our final use case, which is energy savings for a lighting. It's smart lighting. In areas like electrical rooms or tool cribs, motion sensors turn on lights, but we don't want them shutting off the second someone stops moving. When motion stops, the T off timer keeps the lights on for, I just use 3 seconds here, but you could change the preset to 1 minute or 2 minutes. The input goes false, the timer starts, and we use the timer timing bit to keep the work light on. Say we detected a motion, and once the motion is detected, the person in the room leaves, the motion is no longer detected, but we want the timer to be on, the work light to be on for 3 seconds. So I'll just make this 10 seconds so we can see. So motion is detected, and the moment motion is not detected, the timer will be timing, and I just use the timer timing bit as a ceiling to keep the work light on. So this way, while the person is inside the room, the motion detected is high, we want the light to be on, but the moment the person leaves the room, we want to seal it with this timer for 10 seconds. So when I toggle this, I'm saying the person left the room, but I'm using the timer timing bit to branch around the motion detected to keep the work light on. This is a great way to save energy while keeping workspaces comfortable. T-off timers are often overlooked, but they are incredibly useful for more than just fan delays. We have now seen 5 creative ways to use them in your automation projects, from safety to energy savings. And you could download this PLC ladder files for these examples. I have included a free download with all the PLC ladder files for these examples. You can find that in the video description. If you like this video, please give it a thumbs up and subscribe for more practical PLC programming content, and drop a comment below. Let me know which T-off use case you're planning to use next. Thank you. See you in the next video.